In this video, we're going to examine how to divide a polynomial by a binomial. If you have more than one term that you are dividing by, you're going to have to use long division of polynomials. So the way this works is we look at the first one, we have c squared minus c minus 30. I'm going to set that up inside of our division. And then I'm going to put my c minus 6, what I'm dividing by, on the outside. Now the key for doing long division polynomials is organization of work. You have two terms on the outside, and so your first part of the answer is going to go over the second term. The second thing you need to realize is the whole point is to eliminate the largest term. You want to eliminate the c squared, just like you do with numbers. So you have to look, what do you multiply c by to get c squared? And you would multiply c by c. And so you take your number, your value, and you're going to distribute it down to both terms. So c times c is going to give me c squared. And these two numbers should always match because you're trying to eliminate it. C times negative 6 is negative 6c. Now, you have to remember when you're doing long division and you get this, the whole point is to subtract what you have. And so the first one's very easy because you're trying to eliminate it, and c squared minus c squared is going to eliminate each other. They're going to cancel each other. The part that you need to remember is you are actually subtracting a negative 6. And so since you're subtracting a negative 6, you're really adding your 6c. And so negative c plus 6c is going to give me 5c. And so now I drop down my negative 30. And I do the same idea I did before. The whole purpose is to eliminate the largest term like I did here. So I want to eliminate the 5c. So what do I multiply c by to get 5c? And that would be a positive 5. And I distribute 5 times c is 5c. 5 times negative 6 is negative 30. And again, you subtract the entire expression. And so the first term should always cancel. That's the whole point, to eliminate the largest term. The second term is where a lot of the mathematical errors occur. You are subtracting a negative 30. And so since you're subtracting a negative 30, you're really adding 30. So negative 30 plus 30 is 0. And this number represents your remainder. And it's nice when you have a remainder of 0, because then we don't have to take it in consideration with our final answer. So the answer when you divide c squared minus c minus 30 by c minus 6 is our c plus 5. That is the answer. Now, if we look at number 2, you may think, well, it's set up a little bit differently. This isn't long division, but remember, a negative exponent actually means you move it to the bottom. And so really, I'll put this example up here. It's s squared plus 4s minus 16. And the negative exponent means this whole parentheses gets moved to the bottom. And so it's the same idea. You're doing division. So if you see a negative 1 exponent, you're still doing long division. So I'm going to set it up as I did before. I have my s squared plus 4s minus 16. And I'm dividing by s minus 6. So in this example, you saw that I used my parentheses, my minus sign, and I distributed it. I'm going to show you how to distribute it right away, and maybe you will not get the mathematical errors that occur by missing the minus and the minus. Again, the whole point is first look how many terms you have. 2 terms. So I'm going to go over 2 terms. My first answer is going to go over this 4s. And the whole point is to eliminate the largest term. So I'm going to focus on the s and the s squared. You know, what do I multiply s by to get s squared? And that would be s. And you notice, you know, my variable above my variable, my constant above my constant, variable above the variable. It stays very organized that way. And you can see if you have the right expression, the right variable or number in the correct spot. And so you distribute s times s is going to give me s squared. And remember, your first number should always match what's above it because you're trying to eliminate it. S times -6 is -6s. Now, the whole idea is to do subtraction. And so if you're subtracting, you're doing the opposite. And so what I'm going to do is I'm just going to change the opposite signs of these. So it's, you know, I'm going to put my negative here and change this opposite to a plus. And then I just work vertically for it. You know, s squared minus s squared is going to cancel each other out. 4s plus 6s is 10s. So I have 10s. I drop down my -16. And then again, I look at my first terms. You know, what do I multiply s by to get 10s? And that would be a positive 10. And so I put my plus 10 here. And I distribute 10 times s is going to be 10s. 10 times -6 is going to be -60. Now remember, you subtract. And so I'm going to change all the signs in the bottom. So this is a positive 10 becomes a negative. The -60 becomes a positive 60. And then I just do the operations. The whole point is to eliminate the first term. And so my 10s minus 10s, they cancel each other out. I have -16 plus 60, which is going to be 44. And so now this one's different. We see here we actually have a remainder that is not 0. And so we have to take that into consideration when writing our final answer. So I'm going to give myself some room to write my final answer. The s plus 10 is part of the answer, but we have to put our remainder on. And you need to remember what the remainder means. The remainder means you have 44 over what you divided by, still there, still remaining. And so since that's a positive 44, I'm going to do a plus 44 over, what did I divide by? My binomial s minus 6. And so my final answer is s plus 10 plus 44 over s minus 6. So your trick with the remainder is to take your remainder and put it over what you divided by originally at the end. If this were a -44, this would be a minus sign. Since it's a positive 44, it's a plus sign. And you just put your expression in front of it. So this is brief examples on how to do long division with binomials into a polynomial. The key is organize your work